One of the most fundamental reasons life exists on Earth is the abundance of liquid water on its surface. Evidence suggests that life probably began on Earth in the ocean at least 3.5 billion years ago. So when it comes to searching for alien life beyond our planet, water worlds are expected to be our best shot. Within the last 3 decades, astronomers have confirmed the existence of more than 5,000 exoplanets. And recently, a super-Earth that possibly harbors a global liquid ocean has been added to that list. So how did astronomers discover this distant exoplanet? How do they know it harbors a planet-wide ocean of liquid water? Finally, and most importantly, what are the chances that life exists on this water world? Named TOI 1452b, this exoplanet lies just 100 light-years away from the Earth, in the Draco constellation. Its existence was first hinted at by TESS, which is NASA's Transiting Exoplanet Survey satellite. Since its launch in 2018, TESS has been searching for exoplanets in an area 400 times larger than that covered by the Kepler mission using the transit method. The transit method is one of the most conventional ways to search for exoplanets. When a planet passes in front of its parent star in our line of sight, a dip in the starlight is observed. By studying the light curve of the parent star, astronomers determine the existence of a planet around it. Parameters such as the planet's orbital period, mass, and size can be directly calculated by analyzing the light curve. Following the same criteria, TESS found TOI 1452b orbiting one of the red dwarfs in a close binary pair. Here, TOI stands for TESS Object of Interest. In this case, it's the red dwarf star. The number 1452 is the target number in the catalog, and the alphabet B shows that the planet discovered is the first one found around that star. So together, TOI 1452b is the first planet discovered around the 1452nd star in the TESS Object of Interest catalog. The signal recorded by TESS showed a dip in brightness every 11 days. This hinted that a planet was possibly orbiting one of the members of the binary dwarf system. The binary stars are separated by a distance of 97 astronomical units. Although it's 2.5 times the distance between the Sun and Pluto, both the stars appear as a single point of light to TESS. However, the follow-up ground-based observations conducted at Mont Méganic Observatory in Canada played a crucial role here. The observatory's PESTO camera resolved the 2 stars and determined that the exoplanet is orbiting the larger of the 2 stars, TOI 1452. In this image from the research paper, one can see the visual binary being partially resolved by the PESTO camera. This was further confirmed through subsequent observations by a Japanese team as well. Once the planet's presence was confirmed, the next task was to use the observations to derive the physical properties of the planet. The amount of dip occurring in the starlight depends upon several factors, the most important being the size of the transiting world. So, by analyzing the dip in starlight measured by both facilities, astronomers concluded that a super-Earth, almost 1.672 times the size of Earth, was orbiting TOI 1452. Furthermore, as the signal showed a periodic variation in brightness every 11 days, it was clear that the planet takes only 11 Earth days to revolve around its host star, compared to the Earth, which completes one orbit around the Sun in almost 365 days. A shorter orbital period meant TOI 1452b lies exceptionally close to its star. Nevertheless, the host star, in this case, is extremely cool and dim compared to the Sun. Due to this, the planet falls into the star's temperate zone, where the temperature is suitable enough to allow liquid water to exist, which further hints at it being suitable to possibly support water-based life. This prospect made it even more exciting to look deeper into the planet's characteristics. The next important parameter to be calculated was the planet's mass, and for that, astronomers used the radial velocity method. This method relies on the fact that whenever a planet orbits a star, a gravitational interaction occurs between the two, and because of that, the star doesn't remain stationary. Instead, it usually moves in a small circle or an ellipse in response to its smaller companion's gravitational tug. Such fluctuations in a star's position affect its light spectrum as viewed from a distance by an observer. For a star moving towards the observer, the spectrum appears slightly blue-shifted, while for a star moving away, the spectrum is red-shifted. The spectral analysis reveals the strength of the gravitational interaction between the two celestial objects, and indirectly, the planet's mass. In the case of TOI 1452b, the analysis revealed the exoplanet to have a mass 4.82 times that of the Earth. Further, its density was calculated using the planet's mass and size. The density surprisingly came out to be 5.6 grams per cubic centimeter. This is extremely close to Earth's density of 5.5 grams per cubic centimeter. Now, this makes things more interesting. The density of a body represents the amount of matter contained in a fixed volume. So, if a planet, almost 5 times more massive than Earth and just twice in size, has almost similar density to Earth, it should be composed of a lighter material compared to Earth's composition, which basically comprises metal and rocks. To find an explanation for this, researchers modeled the exoplanet's interior. In this graph from the paper, you can see theoretical composition curves for different exoplanets corresponding to their masses and radii. All these curves have been plotted using different interior structure models from various studies. The position of TOI 1452b on this graph shows that it is either a terrestrial planet with a thin hydrogen envelope or a water world with a rich water interior, containing almost 25% water by mass. Water makes up less than 1% of Earth's mass, so if the models are accurate, TOI 1452b's composition seems closer to that of Europa, which is a possible water-laden moon orbiting Jupiter. The existence of water worlds like this has been predicted for years, but it's the first time a suitable exoplanet candidate has been found. However, it's still impossible to say what TOI 1452b is precisely made up of. This is where we expect Webb to prove to be of great help. Webb can deeply analyze the changes in starlight spectra as it interacts with a planet's atmosphere. This lets it indirectly peep into an exoplanet's atmosphere to know what it contains. So far, TOI 1452b is considered the best candidate for a water world. However, we will have to wait to see what new things the James Webb Space Telescope discovers about the exoplanet. Detailed atmospheric observations by Webb could also confirm if life exists on this distant world or not. This concludes the 24th episode of the Sunday Discovery series. If you enjoyed this episode, make sure to like it, subscribe to our channel, and press the bell icon so that you don't miss any future videos of this series.